Hello everyone, welcome to Codescamp. Codescamp is back with an interesting video on the hack to solve BFS or breadth first search problems. Do you believe me if I say these 11 problems can be solved using the same code? Yes, I'm here with a cheat sheet that helps you to solve all BFS problems using the same algorithm. If you're a newbie who's struggling with identifying and solving BFS problem, then this video is for you. By end of the video, you'll feel confident about identifying a BFS problem, cracking the logic of the problem, and implement it programmatically with an efficient code. So follow along. So BFS problems are one of the commonly asked problems in many interviews, mostly in very big companies. So we are here to identify a BFS problem. For example, if a problem is given to you, how do you think that you can solve that problem in a BFS approach? So once you complete the video, you'll genuinely be able to tell whether you can approach and solve the problem using BFS or not. But to start with, there are few keywords with few clues where you can think that a problem can be solvable by BFS. For example, find the shortest path, longest path, or max area or min area, or minimum steps or maximum steps taken in a grid, maze, graph, or in fact island. So if you want to explore all the coordinates of a given structure in all possible directions, then you can go for a BFS. Or if you want to calculate the area of certain portion of a given graph or matrix. For example, mostly the questions will be asked like find the shortest path from the starting node to ending node. That requires us to explore all the possible paths in the matrix and pick a shortest one or longest one if asked. Or if you want to calculate the max or min area in a given figure, and for that you want to measure all the areas or subsets of the figure and pick the max area. Hope it's not confusing, but trust me and follow along. So today in this video, we are going to discuss about these 11 BFS problems. I have listed out medium to hard level problems in my blog, and I have also provided the link to the blog in the description. This blog has the problem statement and solution for all 11 problems, and also the link to the LeetCode site where you can hit the link and practice your solutions. So we'll first start with few problems in a little more detailed way. As we progress, we are going to understand the logic and approach. So we analyze the logical tweak needed for the rest of the problems. First, we want to understand how do we approach a BFS problem. For example, which data structure to use and how do we think and all that. So to start with, the best problem to start with is max area of islands. So the problem statement says it has given m cross n binary matrix and ones represent land and zeros represent water. So we are going to calculate area of an island, and the area of island is having all ones and also surrounded by water all four directionally. So in this case, and we have to return the maximum area of the island. So this is what the output is, they needed. So now if you see, this area is an island and this area is an island that adds up to 4 and 5, and this is 6 and the rest of them are 5 and 4. So this is the maximum area of an island in this particular graph, which is going to be our output. So if you see, we are going to analyze the subsets of the matrix and calculate which is having the maximum value and return it. For example, if a graph is provided, if this is the island, then we are going to start from this particular node if it is having one, and then explore all its neighbors four directionally, that is upwards, left, right, and then down, and calculate. If it having 0, then we are going to skip. If it is having 1, from here we are going to check how the island expands. So from this point we are going to calculate again its right, left, down, and so on, and calculate the total ones connected to each other, and then save it in a value, let's say result. And we are going to analyze all those such areas in the graph and compare all the results and going to return the maximum value. So instead of understanding and going deep into the problem, here I'm going to mention the hacks or the pattern each algorithm follows to solve the problem, so that we identify similar BFS problem and solve them all using the same approach. So I would say if you are a newbie, there are 5 steps or 5 hacks that can help you solve these problems. For example, the first one is a very obvious one. So any m cross n matrix can be solved using two for loops. That is, any matrix structure needs two for loops. So definitely we are going to have two for loops in our code. So here, instead of dividing them into logics and all, I'm directly splitting them into code blocks and making you to understand that these code blocks are really repetitive in all the problems. So this is pretty straightforward. And the second one is, the problem clearly mentioned we need to explore them four directionally. So any BFS problem that explores from top to bottom or explores subsets of the matrix requires us to validate them in four directionally. So we need to calculate the coordinates four directionally. For example, let's take this particular island in this given graph. So this one starts at the coordinate 2 comma 0. So if we are going to iterate four directionally and identify, then the next step is to identify the coordinates, which is 1 comma 1, 2 comma 2, 2 comma 0, and then 3 comma 1. So these are the coordinates four directionally, and these four directionally we are going to again check if it is 0 or 1 and then further proceed from there. For now we have to calculate the coordinates four directionally. Let's say it is not just 2 comma 0, sorry, 2 comma 1. It can be 3 comma 5, 4 comma 5, any value, any box in the matrix. If we want to calculate its four directional coordinates, then for any cell we need to add minus 1 comma 0, 0 comma 1, 1 comma 0, and 0 comma minus 1. So these four values, adding these four values to the current node values will give you the four directional values. So you need a structure to remember these values, so that with each cell we are going to add these four values to find its four directional coordinates. So I am going to declare a integer matrix of size 4 comma 2, and then I'm going to add the static values, because we definitely know these four values are going to help us to calculate the four directional values. So we are just going to declare a static integer array to help us calculate it. So inside our for loop, I'm going to iterate again these four coordinates, like the size of the directions, or again four sets. With the current coordinates values, it is going to add direction of 0 and direction of 1, which is nothing but, for example, this is our first direction. It is going to add minus 1 to its x coordinate and 0 to its y coordinate, and find a set of coordinate, and it repeats four times to figure out all four. For example, if our current 0 comma current 1 is 2 comma 1, then after these iteration, the values are going to be 1 comma 1, 2 comma 2, 2 comma 0, and 3 comma 1. So these four values will be found in this iteration. Pretty simple. So moving on to our third step. For example, if you have traversed this particular island. So in that case, you might have traversed this part and then move on to this particular column, which is, I believe, 2 comma 2. So from 2 comma 2, you further explore. So once you're done, for example, every time you'll start your island at some point and think this is the starting point, and further you have to explore all the connected nodes. So again, when it comes to 2 comma 2, you think your island starts at this point and calculate whichever is connected with this. But that is a repetitive process, because this point has already been visited and checked along with this starting point, which is 2 comma 1. So instead of repeating it, we just have some marker that says this node has been already visited. You don't have to visit again, just skip and go to the next unvisited one. Pretty simple, right? If you have already gone through a particular node's value, you need to put a stamp on it saying it is visited. So you don't have to repeat the process, and that gives us a optimized algorithm. So third step is, we are going to identify if a node is visited already or not. So for that, we are going to have another array, which is a boolean array, which is called visited. So every time you visit a node or iterate a node and calculated its value or done with whatever operation you want to do, then you are going to mark it as true, which means in future iterations, you check if the node is visited is equal to false, then you proceed and check with your operations. If not, if it is true, you can skip it. So this is one way of doing it. It is a very pretty straightforward way of doing it, but it requires big O of n space complexity to have an extra array to track this. Instead, you can sometimes have it. If not, for an efficient space algorithm, you can mark in an existing array. For example, if your given input array is ARR, then if you have already visited, the given values in the array is zeros and ones. So you can mark the array's current value is equal to 10 or 20 or star or any other sign which will not be present in the array to mark that is visited. So next time you check if it is not 0 or 1, then it is visited and you can skip. This is a slight deviation from this method to mark an existing array is visited or not by a different value in the same given input array, so that we don't have big O of n space. Instead, we can finish this algorithm is in big O of 1 space. And the next logic is very, very important logic for any BFS problem, which is which data structure to use. So you now understand how the operations are working. Like, for example, you just start with a node 2 comma 1, and then you are going to explore its left, right, top and down. So if you see diagrammatically, its top and left, that is 2 comma 1's top and left, are actually zeros. In that case, you will ignore them, and the right and down are having ones. So you are going to add, let's say, let us add all the coordinates. So here, if you see 2 comma 0 and 1 comma 1 are having zeros, so we will skip them. So 2 comma 2 and 3 comma 1 are having ones. So in that case, what we will do, we will consider this node is having a 1, and then take 3 comma 1 and 2 comma 2 and explore its four directional coordinates, and then whatever area it covers, we will add them, for example 2 and 1, and then the total will be the area of the array. So we need a data structure that keys in a coordinate, and then once it is done, we will remove it and further proceed with its neighbor, and we keep on adding something, and then we will finish all the coordinates that are added. So let me erase them. So as we discussed clearly, we need a data structure that allows us to keep on adding coordinates, and we should be eliminating the one we are done with. And finally, we'll be repeating the same steps or the calculation until all the nodes are done. So we are going for a queue, priority queue or queue, anything that depends on the problem requirement. So first we feed in the coordinates and then its four directional neighbors, and then once they are iterated and done, we'll be popping them out, and once these coordinates are done, then we will be adding their children or neighbors, and it goes on, and one by one we'll be eliminating each of them, and after their calculations are done, and once the queue is completely empty, then we are going to quit. For example, how does it work is we just feed in this first coordinate 2 comma 1 into it, and then its neighbors into the queue. Once 2 comma 1's neighbors and all added, we'll pick them for calculation and calculate the area, and then it's from its neighbors, we will add its neighbors and etc. Once all the nodes with one is done, then we are going to quit it. Same way we'll initiate it with the next island we iterate to, and then the next island's beginning position, and then the next island's beginning position, and finally we record the area and finally return it. It may sound confusing, but let's consider this as a hack that we are going to use a queue data structure for all our BFS problems. Blindly, you can go for it. And we are almost there. We are yet to done with our fifth step, and our fifth and final step is that our eligibility to add our nodes to our queue. So we can't add every node in the, of course, we have to iterate all the nodes, but as we said, there are certain criteria for the operations. For example, if it is 0, we don't have to iterate because it is not a island, and etc. So we need to add eligibility condition to our queue to have the values. So before that, let's see the algorithm here. So if you see, we are going to declare a queue data structure, and then we are going to offer the nodes into our queue. So now, since we are adding the nodes to our queue, this iteration will go till the node is empty. So every time we enter the loop, we are going to pop or poll a first node that is present in our queue, and then perform our operation. And then by end, we keep adding more nodes, and it goes on till our queue is empty. Once our queue is empty, we'll quit that loop and come out of it. I'm not saying this algorithm is like perfectly structured and perfect syntax and all, but this is an ideology. By following the same ideology, we are going to finish, or we are going to approach all of our BFS problem. So the next thing is eligibility, as I said. So if you see, we are going to calculate our 4 direction using this 4 coordinates. So if we are starting from 0, 0, then these 4 coordinates are going to be -1, 0, 0 comma minus 1, and etc. So in this case, -1 comma 0 and 0 comma minus 1 are not a valid coordinate because it goes out of the matrix. Same way, if we are having a 4 cross 4 matrix, then it is going to calculate 5 comma 4 and 4 comma 5. So these coordinates are not actually valid coordinates. These coordinates go out of the matrix. So in that case, we need a condition that always checks if the coordinates are valid, and depends on the problem statement, we add some more conditions. For example, if the node is already visited or not, and etc. And then we are going to put only valid coordinates into our queue. That makes our operations simple. So if you see, we are going to add if condition before offering the nodes to our queue, which is our I coordinate should be greater than 0 and within the length of the matrix. Same way, j should be with greater than 0 and within the length of the matrix, and grid I comma j is equal to 1, which is nothing but specific to this particular problem. So only if it is 1, we are going to iterate and calculate. If it is not 1, then we are going to skip the node. Same way, we can add one more condition that node visited is equal to false. Only if it is not already visited, then we are going to perform our operation or put the coordinates into the queue. So only these 5 conditions are going to help us build our algorithm. So first one is we are going to have for loops for iterating the matrix, and the second one is we are going to have directions matrix to calculate our 4 coordinates or 4 directional coordinates of a particular node, and the third condition is having a visited array. Either we can have a separate array to mark our nodes are visited or not, or we can put the values in the same grid array to identify if the nodes are visited or not. And the fourth one is very important one, which is the data structure we use, which is always going to be queue in this case. And we are going to offer the nodes into the queue, and every time we are going to poll a node, perform our operation, and put all its children or neighbors into the queue. And we are going to perform our operation till our queue becomes empty. And fifth one is eligibility for entering the or offering the nodes into our queue. So by following these 5 rules in every BFS problem, you can easily solve them. So let's dive into the problem solution and see if these 5 algorithms or 5 steps help us build the algorithm. So here is the actual working solution of max area of island. Let's go through the solution step by step in order to identify our patterns and how it helps us to solve this problem. So first, as I said, we are going to check if we are going to declare the basic variables, like we are going to check if grid is the input. If grid is not equal to null and length is not equal to 0, then if it is 0, then return 0. This is a very basic condition, like edge cases you'll always check in any algorithm. So the first step is to check for the edge cases if the grid is null. If not, we need a result variable, which is what we are going to return. Result is nothing but our max area here. So we need a variable that takes that always calculate the maximum area from all the areas available. So here is where we do a basic math algorithm like math.max. It checks which is the max value, whether current value is the max value or result value is the max value, and assign it to the result. This is very basic steps you should be understanding by now. And current is something that is the area we receive from our BFS algorithm every time and compare with result. So I always like to split it, like the main method will have the very basic stuff and the BFS method will have the actual logic needed for the BFS steps. Or you can combine it together in a simple or single method as needed. So it's totally up to us how we build our algorithm. So this is one of the patterns or easier patterns you can always follow if it works for you. And I do show different patterns in different algorithms so that you can pick whichever works for you. So this is one of such patterns where I handle the very simple steps in the main method. So here, as I said, we need two for loops to iterate our grid, which is nothing but our m cross n matrix. So you are all aware of the for loop, how to iterate a matrix and all that. And what we are going to do here is first we are going to check if the node is 1, having the value 1. Only then we are going to consider that as the starting of the island and then send it to our BFS method to check what is the maximum area of that island starting at this position. For example, our first island in our given graph was at 2, 1. So we are going to consider 2, 1 as our starting point for our area, the sub area, and then we are going to pass that 2, 1 to our BFS method and ask it to calculate the area of that particular subset. And it returns result, which is nothing but the area of this particular island starting at this position. So we are going to check if it is equal to 1, then we are going to call BFS. We are sending the complete matrix as the input, and I comma j is nothing but we are going to consider this as the starting point of our island, and it is going to return this complete island's area as the result. That we are going to get in current, and we are going to check if it is greater or the max value among them and then return the result. Finally, after all the iteration, we are going to return the result. So this is pretty simple, like very simple algorithm, like finding the max area of or max value in a given array or something. So we are going to get the value every time from our BFS algorithm. So let's now go into the actual BFS algorithm and look at the patterns. So here we are receiving the complete matrix and the starting position of our island. As I said, we are declaring a queue. This is our first or the very important step in an algorithm, the data structure we are going to use. So as we already know, K and L, which has been the first starting point of the island, which is obviously going to have 1 as its value. So we are going to offer it to our queue as the first step. And result equal to 0 is a common variable. We are going to assign our result and return it. And as I said, we are going to iterate it till the queue is empty. And we are going to poll the value, first value in the uh, queue which we just offered, and we are going to take that as a current value and result plus plus. Result plus plus is nothing but result is the area we are going to send. So area is nothing but addition of all the ones in the subset or the island. So result plus plus is nothing but each time we come across a cell which is having a value 1, it is going to iterate one more time to calculate the area. So as I said, we are going to declare an integer array that calculates all 4 directions. Here I declared it with the name neighbors. You can put it as directions or however you like it. So as I said, again, we are going to iterate it for the number of times the neighbors we have. And every time we are going to calculate all 4 coordinates, which is nothing but current plus neighbor of 0 and current of 1 plus neighbor of 1. So it calculates 4 different coordinates for each cell we put in. So in this case, we passed 2, 1 inside the queue, and queue polled and got in current 2, 1. So current is having 2, 1, and it is going to find all 4 directional coordinates of 2, 1. And as I said, again, we are going to check the conditions greater than 0 and within the length of the matrix, greater than 0 and within the length of the matrix, and if the value is equal to 1. Then we are going to offer the value into the queue. And that's it. Every time it iterates again to the same loop until the queue is empty, and find the total area of that island and return that as a result. So it goes in and saves as part of the result. So now the area, let's be 5, and we are going to assign it to result, and again it iterates, and if it is 1 only, it is going to check. So whenever it come across the next island, then it is going to pick that coordinate, pass it to the BFS. BFS calculate the area of that particular island and return it. So here we missed two things. One is grid of I comma j is equal to 0 here, and grid of I comma j is equal to 0 here, which is nothing but the step we discussed. Like we have to stamp the cell saying it has already been visited. So here we are going to check the values only if the value is equal to 1, right? So in that case, if we make the visited node to 0, then we are not going to consider it again, which means we are not going to repeat it or check it again. So we are just setting it simply to 0 here, saying this node is visited. So once we calculated a new node and calculated its result, then we are going to set it to 0 and offer its neighbors to the queue. So every time we calculate a new coordinate, we are going to check if it is valid. Once it is valid, we are going to mark it as visited and then offer it to our queue. So this step can be interchangeable. Like first you put it into the queue and then mark it to 0 also works. So this is how we handle it. And also every time we check the first node and mark it as 0, then we are going to, like, once the node is being considered as 1, then we are going to mark it as 0. Why? Because this is the first node we are going to offer into the queue. Here in this iteration, we are offering only its neighbors to the queue, not this particular value to the queue. So it is necessary to set it to 0 here also. So this is the whole algorithm. Hope I made some sense. But if you see, it has followed the same set of code and same pattern to solve it, and without any extra step the algorithm has already been solved. We have seen the previous problem in a very detailed way, so now we are going to skim through few problems from the list I have shown to understand if really the pattern we have seen helps us to solve other BFS problems as well. So the next problem we are going to see in this list is last day, where you can still cross. So the input given here is a one-based binary matrix where 0 represent land and 1 represent water. So the input actually given is not the values in the matrix, but instead the size of the matrix, which is row and column integer values that represent the size. So if you see row is equal to 0 and column is equal to, row equal to 2 and column equal to 2 is the first input. So let's say our matrix looks like this, a 2 cross 2 matrix, and then it says on day 0 the entire matrix is land, which means the entire all the values in the cells of the matrix are going to be 0 on day 1. And however, each day a new cell becomes flooded with water. You are on given one base 2D array cells, and which represent on ith day the cell on the rth row and cth column will be covered with water, which is nothing but they have given an extra input called cells, which is an integer array which represent which cell will be a water on that particular day. For example, if the value is 0 1 2 3, on 0th day cell 1 comma 1 will become flooded with water, and then so on, and on day 1 2 comma 1 and day 2 1 comma 2 and etc. So you want to find the last day that is possible to walk from top to bottom by only walking through lands, and you can start from any cell in the top row and end at any cell in the bottom row. You can only travel in 4 cardinal directions, which is left, right, up and down, which means you cannot travel diagonally. Return the last day where it is possible to walk from top to bottom by only walking on the land cells. So what the problem says is, first day all the cells will be 0, and on each day each cell will be filled with water. So you want to start from any cell in the first row and finish in any cell in the last row. Basically you have to travel from top to bottom via land because you cannot walk via water. So you have to figure out a way from which top cell to bottom cell it can start and end. Though we are going to use the same pattern to solve this problem, there are few logical tweaks that are very specific to this problem that are needed to be added. So let's understand that before getting into the coding part. So here, as they said, we are going to find a way from starting cell to the ending cell via land. So in this case, what could be our output? It is the maximum day that we can cross from the top to bottom cell. So how many days? Is there an infinite limit or is there a defined days and etc.? If you see the input, there are 4 days input that is given. So in this case, the output is either going to be the 0th day, first day, second day, third day to fourth day. So the output is definitely going to be from 0 to 4. So considering this option, we can refine our algorithm based on it. Like we can check on 0th day whether we can cross or not, and again on the first day whether we can cross or not. If we can cross, then we go to the second day. If we can cross, then we go to the third day. And if we can cross, we still check the fourth day. If not, if we cannot cross, then we are going to send the second day, because the maximum day we can cross from top to bottom would be 2. So another important thing is the input or the values in the matrix is not static. So each day one of the cell is going to be filled with water. So whenever we consider the day to cross, we have to make sure that we are watering the cell, or we are marking that cell has been watered and we cannot use it. So these are the two things which is very specific to this problem. So let's now go to the coding part and understand. So this is the actual working code for this problem. Similar to a previous problem, in this problem also I would like to divide my logics into two different methods. One is my main method, which has the code very unique to this particular problem, and the other one is my BFS method, which holds the BFS logic. So here, before understanding rest of the main method, I'm just wanting you to understand this part alone for now. Later I'll explain the rest. So here we are calling the BFS method to check on that particular day if we can cross from the first node to last node. If yes, it returns true. If not, it returns false. And based on that value, we are going to return our result here. So we'll see later like how we compute the day and all that. For now, we are considering the input from 1 to the length of the cells. So as we all know, the input is going to lie between 1 to the length of the cell. So we are going to pass each day to this method and check if we can cross on that particular day. If yes, based on it, we are going to calculate the value. So before understanding that, let's go to the BFS part and come back here. The first thing I'm going to do in my BFS method is constructing my input array, because as per the problem statement, the input array is not static. It is going to change based on every day. So first thing we're going to do is iterate the number of days. So here in our input BFS, we are passing the cells, row, column, and then the day at. The day at is basically going to be from 1 to cell dot length. So on that particular day, what is our input array going to be? So we are going to start from 0th day to that day and fill our grid, that is input grid, which is having all zeros with ones in whichever place applicable. So this is going to be our input array. So this is very specific to our problem, this current problem, not necessary for other problems. And as I said, I'm going to declare a queue, and all BFS problem is going to be having a queue, and we are going to fill the queue, and we are going to iterate the queue till it is empty. And once it is all empty, we are going to return our result. So what are we going to fill in our queue? So as we know, the input statement says we are going to start our traversal from the first row, any cell, and then till the last row. So if our first row is having 0, 1, 0, the middle cell is not eligible to start our travel from. The first and last cell is only eligible. We can start from only the first and last cell. So our first node, the starting point of our path is going to be any node in the first row. So what we are basically going to do is we are going to iterate the number of columns, which is the number of columns, and then we are going to check if any cell is having the value 0, then we are going to offer it to our queue. Why? Because the 0 is land, and that is the eligible node to start our iteration from. Usually we'll check the eligibility later in the loop, but this is specific to this problem. So we are going to add all the eligible nodes from the very first row to this grid and making them to 1, because we have started our iteration already from that node. So we are considering them as visited. So this is nothing but marking that node as visited already. Hope you are following me. So since we added the eligible nodes in the grid, we are going to start our iteration checking if it is empty. Then if it is not empty, we are going to poll it and perform our operations on that particular node. Operations are nothing but starting from this particular node, how we can travel from the first node to the last row. So we are taking the row and column indices from this current node. So current node is going to have any coordinate, let's say 0, 0. So our row is going to be 0 and column is going to be 0 is what we are assuming here. And if we reach the last row, then the row is going to be total row minus 1, which is nothing but if it is a 2 cross 2 matrix, and the index is going to be 1 at the last row. So here we are checking if we already reached the last row, because we are polling each coordinate from the queue, and if one of the coordinates is already reaching the last row, which means we already crossed the path, which means on that particular day we can actually cross from the first row to the last row. So we are simply going to return true. So this is applicable to any node that is in the queue, because if either one path exists from the starting node to ending node, then on that day we can cross. So it is going to return true. If not, we are going to iterate and find its 4 directional coordinates. So here there is a difference between the last problem and the current problem, which is calculating the 4 directional coordinate using a different kind of array. So usually I said we'll declare a 2-dimensional array with coordinates that we add with our current coordinate to find out the 4 directional array. So instead of a 2-dimensional array, we are declaring a single dimensional array and arranging the values in such a order that the adjacent gives the same coordinates as that of 2-dimensional array. So if you see 0, 1, 1, 0, 0, minus 1 and minus 1, 0. So it is a very simple trick to reduce or optimize space. And you can still go for the 2-dimensional array and that works, but it's a simple trick to optimize space. And once we calculate all 4 coordinates for a particular cell, then we check the eligibility to put them into our queue. As usual, we check if it stays within the matrix sizes limit. And then if the value is equal to 1, then simply continue. If not, if it satisfies, then we are going to put that into our queue. Before putting that into our queue, we are updating the grid value to 1, marking that it is visited. So it's not, instead of using an extra space, we are marking the same array to 1 so that we consider it as visited. So it goes on and on and on and calculate its coordinates, and then if it is 0, then it puts into a queue, and further it goes and goes and goes, and finally here is the check. If at all any one of the coordinates that is in the queue has reached the last row, which means we have traveled from the first index to the last index, so we are going to return true. If none of them reached the last row, which means, and we completed the entire queue and it is empty now, then in that case it returns false. So this is how the BFS part of this problem works, and here we check if it is true, then we are going to consider that day, that we can cross from that date from start to end. So here there is a simple trick again to optimize the algorithm and to reduce the time complexity of the algorithm. For example, we have already done a series of binary search videos, how to approach a binary search problem and how to find a binary search problem. So if you're not someone who is familiar with the binary search problem, I would highly recommend to go through those video series to understand, and that will help you to come up with a very optimized and good algorithms. So here also we have implemented binary search in order to optimize our algorithm. So as we know, the value is going to be 1 to size of the cell, our result is definitely going to lie somewhere between 1 to the max size. So in this case, instead of iterating from 1 to the size of the cell, we are going for a binary search approach which calculate the mid value, and every time it passes the mid as the date. For example, if the value is between 1 to 10, we are going to consider 5 as the mid value and pass it as 5. If he can cross on the 5th day, which means our output is going to lie somewhere between 5 to 10. If he cannot cross
then which means our output is lying somewhere between 1 to 5. By using this method, we are reducing our computation by half instead of iterating from the initial to end value. Same way again, if it is 1 to 5, then again we are going for the mid value operation, and then it is going to be 3. We are going to check if we can cross from 3. If we can cross, then the value is going to be 3 to 5. If we cannot cross, then the value is going to lie between 1 to 3. So this is how the binary search keeps on going. And if the value is going to be true, then which means we can cross on that particular day. So our days is going to be mid for now, which is what we are going to return at the end. And we are going to put our left pointer to mid plus 1, which means if it is true, for example, we are passing 5, and if it is true, which means he can cross on 5, which means our output is going to lie between 5 to 10. So the right is going to be, left is going to be mid plus 1. From 1 we are going to shift our left to here. If in case it is false and we cannot cross on the fifth day, which means our output is going to lie between 1 to 5. So our left stays the same, but right navigates from the end to mid minus 1. Hope you understand. If you are not understanding, please go through binary search problem and understand what is binary search. That will help you to come up with a very good optimized algorithm in this case. So if you still don't want to go for the binary search because it feels complicated and all, you can, instead of iterating and calculating mid and passing it, you can simply declare left is equal to 0 and do a for loop from left is equal to 0 to size, and then pass the I or the left value instead of mid and iterate the complete iteration from 1 to size, and still it works. The same algorithm works. But why I ask you to understand binary search and go for it is, sometimes when you submit your code, even though your code works perfectly fine for the example inputs, sometimes for longer inputs it throws time limit exception, and then still your algorithm fails to satisfy the few conditions. So in that case, this kind of optimizations really help. Hope you understood this solution. Let's go and skim through really quick few more problems. So the next problem we are going to see in this list is Pacific Atlantic water flow. So the problem statement says they have given m cross n matrix of non-negative integers representing the height of each unit cell. So here they have given input as a m cross n matrix with integer values, and each is a height of that particular cell or area or etc. And the Pacific Ocean touches the left and top edges, and the Atlantic Ocean touches the right and bottom edges. So top and left is Pacific and right and bottom is Atlantic. And then the water flows in four directions, which is up, down, left and right, from a cell to another cell with equal or lower height. So find the list of grid coordinates where the water can flow to both the Pacific and Atlantic Ocean. So what they say is the water from Pacific and Atlantic Ocean can flow from one cell to another if the adjacent cell value is higher or equal. So in this case, water flows from top and left is Pacific and right and bottom is Atlantic, and they ask the list of coordinates where both the water flows into the cell. So let's see how we can solve this problem using BFS. Let's understand how the problem logic can be solved. So as they said, the top and left are Pacific. Let's say all the cells in the top row and in the left side column will be filled with Pacific. And let's say green is Atlantic. So Atlantic will be filled in this cell, that is our last row, and then our last column. So already if you see, this coordinate and this coordinate coincide with both Pacific and Atlantic. But then let's see how the Pacific flows now. So here, from if the values are equal or higher, it will flow, right? So from here to here it will flow, from 2 to 3 it will flow, and 3 to 4 it will flow, but 5 to 4 it will not flow. And again if you see, 2 to 4 it will flow, 3 to 5 again it will flow, and 4 to 3 it will not flow, it will stop here. And then 4 to 7 it will flow, 7 to 1 it will not flow, 7 to 1 it will not flow, also 5 to 1 it will not flow, also 5 to 3 it will not flow because 3 is lesser value, and the Pacific stops here. So now let's explore Atlantic. Atlantic will flow from 5 to 4, sorry, 2 to 4 because 4 is higher value, and 1 to 1 because they both are equal, and 4 to 3 it will not flow, but 1 to 3 it will flow. So now it time to check interaction or combination of both Atlantic and Pacific in a single cell. So if you see 3 to 4, 4 is a higher value, so Pacific Atlantic will also fill in this cell. And if you see 3 to 5, again it will fill in this cell. And 1 to 7 it will fill. And 1 to and 7 to 6, 7 to 4 it will stop. 5 to 3, 5 to 4 it will stop, and 4 to 3, 4 to 3 it will stop because those are lesser values. And if you see, these are the coordinates that actually have both Atlantic and Pacific values. Yes, so these are the coordinates we need to send, and also from 5 to 6 it will flow. So 6 is also included. So these are the cells we have to return. So usually in a BFS approach, we will take one particular matrix and see how the path goes or how the flow goes and etc. But in this case, there are two conditions. So how do we approach this? By having two different queues, Q1 and Q2. Probably Q1 explore the nodes where Pacific follows, and Q2 explore the node where Atlantic follows. And then we check if both the cells have same coordinates, then those are the coordinates that have both Atlantic and Pacific water, and we are going to return it. So this is a very pretty simple logic. Let's skim through the code really quick. By now you understand how the pattern and structure of the code will be, so you will be grasping it in within seconds. So now if you see, as usual, I have split my methods into BFS method and the main method, which has the actual logic related to the problem. As I said, we are first checking if the matrix length is 0, which is a very basic check, and returning an empty array list, because we have to return the list of coordinates in list of array list format. And then I'm taking the number of columns, number of rows, and land heights, etc. variables for my calculations, and I'm declaring two queues. One is Pacific and other one is Atlantic. As I said, our left side and top row, that is first row and first column, will be Pacific. So I'm going to offer, and then my last column and last row will be Atlantic. So what I'm going to do, I'm going to iterate number of rows and pass in the first row and last row to Pacific and Atlantic respectively. It's easy for our for loop to calculate this. That's why we split it this way. And also we iterate to number of columns and then put the first column and last column to Pacific and Atlantic respectively. So we are putting the starting point of the ocean, because from here is the starting point for Atlantic and this side is the starting point for Pacific, from where the water flows. So now we are calling our BFS for Pacific and BFS for Atlantic to check where and all the Pacific water can flow and where and all the Atlantic water can flow. So you can have a different kind of data structures or different kind of uh, arrays to calculate it, like can be an integer array that stores the coordinates and etc. But the easier approach is to have a Boolean array. So in Boolean array, we will be marking where and all the Pacific flow as true and not flow as false. Same way to Atlantic. And finally, it's easier for us to compare. And if both the cells equal in both the array, which means we found our interacting or the intercepting coordinates, that we are going to pass as our output. So here at the end, we are declaring a list of integer called common cells, which is what we are going to return as our output. And we are simply iterating both the arrays and checking if Pacific reach and Atlantic reach have any coincide. Like simply we are doing AND operation, because true and true is going to return true. If it is returning true, then we are going to add the coordinates into our common cells, and then we are going to return that as our output. So this is a very simple, pretty straightforward main method. Here a simple tweak which needed was declaring two arrays to calculate two different ideas. Now to our BFS method. As usual, I'm going to declare a queue and I'm going to iterate till the queue is empty. And this is a result Boolean array which I'm going to return. For Pacific, it will return the Pacific values, and for Atlantic, it will return the Atlantic values. And as I said, we are going to poll each coordinate in the queue until the queue is empty. And then we are going to set the result equal to true, which is nothing but marking we have visited that particular cell. So now, as usual, we are going to calculate our directions array, which is missing. Probably I might have declared it before this method. So, and calculate all 4 directions for each particular cell. And I'm going to check if it is less than 0 or greater than the size of the matrix, then skip it. If it is a valid cell, or if it is already marked as true, then we are going to skip it. We could have added this condition in the same for loop. If not, if the land heights is less than the respective coordinates other height, then continue, because we can put in the value only if the value is equal or higher. If it is lesser, then we cannot further proceed in that lane, so we are going to continue. So if none of these conditions are satisfied, then it is eligible for us to flow our water, so we are going to offer that into our queue. Hope you're understanding the logic. We are checking if it is out of the size of the given input, or if it is already visited, or if the value is lesser, then in that case we are simply going to skip the iteration. If none of this, then obviously it means the water can flow through the adjacent cell which has been calculated in this iteration. So we are going to put it in our queue, and we keep on iterating till our queue is empty and keep on adding our neighboring coordinates, and then fill in to true wherever possible. Right? So wherever there is a possibility of pouring our water, then we are going to fill it as true, and then calculate that particular cell's neighbors, and then further explore from that cell whether we can pour the water to the next cell or not. And finally, we are going to return our Boolean array, which consists of true or false values based on whether we can pour the water or not. And finally, we are comparing and sending the coordinates. It is that simple, is it? After 2 detailed problems, you now understood the code in seconds, I hope. So the next problem we're going to see in this list would be nearest exit from entrance in maze, which is quite a different implementation from others. So here the problem statement says we are given a m cross n matrix that represent the maze. So dots are the empty cells and plus are the walls. So you know how a maze looks, right? So they just gave a path in form of dots and then the walls in form of pluses. And as usual, we can go up, down, left and right. And they also give an entrance as an input, which is the entrance of our maze, or where you start traversing through the maze. So now what we have to return is the number of steps in the shortest path from entrance to the nearest exit. And your goal is to find the nearest exit from entrance, and exit is defined as an empty cell, which means whichever cell is having a dot that is at the border of the maze, the entrance does not count as an exit. Okay, so the exit will always be the border of the maze. So let's understand with a quick example and then go to the code. So this is an example maze given in the problem statement, which means these are the walls and these are the dots. And this is where the entrance you are standing. So now from here you have to find the shortest path to the exit, and how many steps you have taken to go to the exit is what you have to return. So now if you see, there is one way to go to the exit, like there are 3 exits. Exits is calculated which are having the dots in the border. So this is one exit, this is another exit, and this is another exit. So let's see how you can travel from your entrance to exit. So you definitely cannot travel to this exit because we can travel only in 4 directional, and this is a wall, this is a wall, you cannot step on a wall. So the next would be having traveling towards your left. So if you see, you take step number 1 from here to here, and then step number 2, and you already reached this entrance, this exit. So for this exit, you have to take 2 steps. And let's see if you can travel up. So if you travel up, you reach this cell by one step, and this is your nearest exit. So you're going to step out in this exit with taking 1 step. So ideally, we have to explore in all four directions and see if you have reached any of the border cell, and then return the number of steps you have taken to reach that cell. And we have to return the shortest one, not anything. Okay, so let's see how we implement it using BFS, which is a very pretty simple implementation compared to other problems. So as I said, we are declaring our direction matrix. Here they named it as shift. You can name it again as however you want to just define the coordinates to calculate our directions. And now entrance of 0 and entrance of 1 is the coordinate they mentioned as the starting point of your maze. So if you are already starting from that point, you cannot exit at that point. So which means we have to mark it as visited. So simply by adding it as plus instead of dot, we are marking it as visited. And then as usual, we are declaring the queue and we are adding our first entrance point to our queue. So usually we will add only the coordinate into our queue as an integer array, which will be a 0, 1 or something. Here we are adding an extra integer value, which I will let you know at the end. So just remember, we are adding 3 values to the queue and the last value is an integer value to keep track of something. Okay, this would be the steps you have taken at that coordinate from your entrance. So now as usual, we are iterating till our queue is empty and we are pulling the node from the queue and iterating till our queue is empty. And as usual, after pulling the node, we are calculating its 4 directional coordinates by adding like shift of 0 and shift of 1 to node of 0 and node of 1. So node is nothing but the pulled value from the queue. And as usual, after adding and finding all 4 neighboring coordinates, we are checking the eligibility. So if it is greater than 0, less than maze dot, that is within the matrix length. And then if it is a dot, only if it is a dot, we can travel through it, right? So in that case, only if it is a dot, then we are proceeding with our calculation. I'll come to this part later. So directly entering here, we are updating it to plus, marking it as visited, because we are standing at some point and then we are figuring out all 4 directional coordinates from by calculating it with the directions array, and we are checking if we are eligible to move in that direction. So if it is only dot, then we can move. If it is plus, we cannot move. So in that case, if it is a dot, then we are marking it as plus because we are traveling via that node, and then adding it to our queue. So again, we are adding a third value here, which I'll let you know at the end. So we keep on adding until the node is empty. And then finally, we have to return our result at some point. So that point is here. And if we did not reach the end of the maze, in that case, we are returning -1. There can be cases. So if at all we are not reaching the end at all, then in that case, we are returning -1. So now if you see this condition, we are checking if x is equal to 0, y is equal to 0, or if one of this condition is met, we are in the border. That is, if we are in the first row, first column, or last row, last column, which means we are near the maze end, exit. So we are at the exit. So that is when we have to return the steps we have taken. So if x is equal to maze dot length dot -1, which means if we are in the last column or last row, in that case, we have to return the number of steps we have taken, which is this. So now let me tell you how we calculate this value and how we are returning it. So if you see, we are adding 0 at our first coordinate added to our queue, which is nothing but our first coordinate is the entry point. So at that entry point, the steps we have taken will be 0. So as we step forward to another node, each step we take, I'm adding +1 to that to track at that particular coordinate how many steps I have taken. You can also declare another data structure, another array to calculate the step at each point, but this is easy because at that particular coordinate, for example, if I move from here 1, 2 to 0, 2, at 0, 2, how many steps I have taken. So at each coordinate, you can easily calculate the number of, you can easily track via this way how many steps you have taken. So at each time we add a coordinate to our queue, I'm incrementing its current value plus 1. If suppose a coordinate 1 comma 2, I have traveled already 2 steps, it will add that coordinate's neighbor and add 3. For example, 2 comma 2 and then 3. So at 2 comma 2, I will take 3 steps. That's what it denotes. And then each time we keep on adding and updating our maze's path and then calculating the node. At some point it will reach the border. At that particular point I'm simply returning node plus 2. The node plus 2 is nothing but the third value in our array which is pulled from our queue. So plus 1 is the extra step you have taken at that particular exit, and then you're returning. Hope you're understanding this simple algorithm. All this algorithm we have seen 4 problems, all of them implemented queue, and it iterates till the queue is empty, and each time it pulls the value from the queue and calculate its 4 coordinates and then check the eligibility, and then based on the problem statement it checks and validates and then return the result. So this is the only part you should be concerned of when you are trying to solve a BFS problem. The rest are going to be constant. It is all going to follow the same pattern. Just the logic you need to understand at that moment when you read the problem statement and solve it. So this is it. I'm going to explain only these 4 problems in this video. Take this as a homework or your task to go through the blog and check rest of the 6 problems, and comment in this video on your understanding of the problem and how you understand the logic, how you cracked that problem, and etc. If you struggle with any problem in the list and you want me to make another specific video on that particular problem, please do let me know in the comments. I'm happy to make another video on that problem. But I hope I covered most of the problems as individual videos in my channel already. I'll add the links in the description. Please do check. If not, if it is still confusing, you should be understanding all the problems by now. But if it's still confusing, do let me know in comments. I'm happy to help. Thanks a lot for watching the video throughout, and hope I helped at least somehow to understand the BFS problem and solve them. Please do let me know your experience, and also let me know if I need to do a part 2 on this video to explain the rest of the problems. Thanks a lot for watching Coders Camp. Have a good day.